Hi everyone, today's lesson is on right triangles. So let's get started with a short review of what a right triangle is. It's a triangle that has a right angle in it. So a couple of things that I do want you to remember is the side opposite the right angle, that's always going to be the hypotenuse, okay? If you were to stand at this angle, by the way, this angle here, plus this angle here also adds up to be 90 degrees. So you have a 90 degrees between these two, plus this angle here, which is another 90 degrees, that makes 180. Just for reference, let's say you are standing here, there you are, and you're standing here at this angle, okay? We're gonna call this X, or you could call it theta. Theta is this is an angle. So you could call this X or theta, but if you were standing here at this angle and you were looking across from you, that would be the opposite side if you were standing here. So it's kind of like if you were taking your arms and you were to say, sort of surround this side, that would be the opposite side, okay? This would still be the hypotenuse, but this side, which is adjacent to this angle right here, this would be my adjacent side. Now, just a note that if you were to put yourself up here, okay, and here you are at theta, or we could call this beta or alpha. Let's do that. Let's call this a different angle, okay? And let's call this alpha. This is another angle. So we call this alpha, this angle right here, which is titled B, but this angle inside here, that's alpha, let's say. Then this angle still opposite the right angle is still my hypotenuse, but this side here, this is now what we call my opposite side. And then the side adjacent or adjoining me here would be adjacent, okay? So it depends actually where you're at will depend on whether the side opposite you is adjacent or opposite. So just to reiterate what we've got here, again, if I'm here and this is theta or X or any angle, across from me is the opposite side. This side right here, which is opposite the right angle, that's always going to be my hypotenuse. And if I'm here, this is an adjacent side. So this right here is called the adjacent side, that VA adjacent, okay? However, again, if I were to erase all this, again, and I put myself, let's say, at this corner right here, there I am, or you, and there's theta, then this here becomes the opposite side. And this side right here becomes the adjacent side. And then again, the side opposite my right angle is always going to be called my hypotenuse. Okay, so just a warm-up. This is something from Algebra 2 that is very important to know for right triangle trigonometry, as to how to reduce a square root. So just a couple of things to keep in mind. A square root, this is my root right here, that's a root. And a root, if you're not familiar with that, let's say we just have the square root of X. There's a 1 here, there's a little 2 here. Those numbers are there, we don't see them, but we know that they're there. If I were to rewrite that, this square root of X, I could write this as X to the 1/2 power. The reason why you would write that a different way is because, let's just say sometimes you would want to know what's the square root of 36. Well, most of you are going to say 6. The reason is, and some of you are going to say, well, why is it 6? Well, actually what happens is remember what we just did right here with the square root, okay? This square root is there's a little 2 in here that we know that's there that we don't see. There's a 1 here that we know that's there that we don't see. So technically I could rewrite this as 36 to the 1/2 power. Now another way of writing 36 is actually 6 squared, right? But you still have this to the 1/2 power. So this is still to the 1/2 power. And what ends up happening is that my 2's cancel and I just get 6. Well, that's why the square root of 36 is 6. Now, a couple of things to keep in mind as well is that when you take the square root, when you have a variable, let's say you're solving, let's say the square root of 36, you get actually 2 answers because the original question was x squared equals 36. And then what happened was you said, okay, I'm going to solve for x and I'm going to square root both sides, which we just know why that happened. That disappeared. But when you square root a square like this, technically you're going to get two answers. You're going to get a positive 6 and a negative 6. The reason being is because you don't know if they're actually saying 6 times 6 or if they're saying actually negative 6 times negative 6. So which one were they using? And you don't know. Now, in geometry, because most of the time we're talking about a length, okay, you're not going to have negative 6 inches or negative 6, feet. You're not going to be measuring negative 6 anything. You're not going to take out the tape measure and go, oh, that's negative 6. Okay, that's not going to happen. So just keep in mind that because it is a quadratic, it's x squared, you get two solutions. But in geometry, we're only using the positive values. Okay, so what we're going to do now is we're going to get started on this warm up, and just to remind you of how to reduce these radicals. So a couple of things here. These are expressions, so they don't have equal signs. So don't just add in an equal sign just because you like to. So basically you can add in, let's say, an arrow. Okay, so a couple of things to remember before we get started with this again. Some of you remember multiplication. So you know that you can multiply root 2 times, let's say, root 3 and get root 6, okay? Or you can divide root 6 by root 2 and you would get root 3, okay? So just a couple of things to remember. Roots you can divide. You can divide a root by a root, and you can multiply a root by a root, okay? So that's just a little bit of review from, let's say, Algebra 1 that you may have spent an entire year last year doing. Okay, so anyway, you're asking yourself, in order to reduce these roots, you want to be able to divide perfect squares into them. So like you're thinking perfect squares. So just to review, 1 squared is 1, 2 squared is 4, 3 squared would be 9, 4 squared would be 16, 5 squared would be 25, 6 squared would be 36, 7 squared would be 49, 8 squared would be 64, 9 squared would be 81, 10 squared would be 100. Now these don't go up quite that much. We could do a couple more. 121 for 11 squared, 144 for 12 squared, 13 squared is 169. For, that's what, 13, you've got 14 squared is 196. 15 squared, 225, 16 squared, you're probably not going to get it much more than that. So we'll stop at 256. So which one of these values down here do you think will divide into 75? Well, if you pick 25, then you're in good shape here. So that's going to be the square root of 25 times the square root of 3. Okay, and again, we can break 75 up by 25 times 3. Square root of 25 is 5, so you have 5 root 3. So that would be my solution or my answer for reducing that. In addition, what we have here is root 2 over root 5. This long root can be divided into two parts. You can say root 2 divided by root 5. What you do need to remember is that you can't leave this root on the denominator. Now, in order to lose the root, and remember, don't leave an equal sign, just make these like forward going. You need to simplify this, and to lose the root on the denominator, you're going to multiply it by another root so that it becomes a perfect square. Well, in order to do that, you're going to multiply it by, let's say, root 5. But the problem is you can't just decide to multiply the denominator by root 5 and not multiply the numerator by root 5. So what ends up happening is you're actually multiplying by 1. And you can multiply by 1 in any form that you want. This is what we're choosing because it's the denominator. So by multiplying by root 5 over root 5 on the denominator, we're going to get the square root of 25. Well, we know that the square root of 25 is 5. So we're going to put a 5 on the denominator. And then on top, you're going to go root 2 times root 5, which is root 10. And so my final answer is root 10 divided by 5. And even though you can reduce roots with roots, you cannot reduce a root with a number. You cannot do that. It has to be a root. So that's your answer. For this one right here, root 64 times root 4, well, the square root of 64 is 8. and times, and then the square root of 4 is 2, so 8 times 2 is 16. So basically you've got 16. Now, keep in mind that the square root of 64 times the square root of 4 is actually the square root of 256. Well, and again, the square root of 256 is 16. For this problem, you have 2 root 48. So try to reduce root 48. So that's going to be 2 times the square root of, let's say, 16 times the square root of 3. Well, the square root of 16 is 4, so we really have 2 times 4 times root 3, which becomes 8 root 3. That's our solution for that value. And then the last one, again, remember, you cannot leave a root on the denominator. So in order to get to eliminate this root down here on the denominator, we're going to multiply by 1, but in the form of root 5 over root 5. So what you have so far is 15 root 5 over root 5 times root 5, which is root 25, which is just 5. Now, this is not my final answer because I can reduce numbers with numbers. So basically, I know 5 divides into itself once and into 15 3 times. So I get 3 root 5, and that's my final answer here. Okay, so what we're going to start talking about for this chapter for right triangles after we did our review is a big part of this is called geometric means. Okay, and a mean, a geometric mean is a proportion because what you're going to get is you're going to get a right triangle. We're talking about a right triangle. And let's say we have another, that's my altitude, which comes down perpendicular. So when they're talking about a geometric mean, what we're really saying is something like this. Let's say that's an unknown. Base is to this height. So it's like leg is to leg as leg is to leg. So you're going base is to height as height is to base. So if this number was, let's say, 5, and this number was, I don't know, let's say 15 or 3, okay, you would say 5 is to x as x is to 3. So it's like a proportion. It's a geometric mean because what they're saying is all these triangles are similar. So you would say 5 is to x as x is to 3. You would cross multiply and you would get x squared is equal to 15. So x equals the square root of 15. And so this would be my solution is the square root of 15. I can't reduce that. That would just be my answer. But that's what a geometric mean is that it's something that is going to be a ratio of 2 proportional sides or 2 similar for 2 similar triangles. So again, we have, what is the geometric mean? It's going to be a is to x as x is to b. And your a and b are sides of your similar triangles. So if one of the questions immediately is going to be asked to you, what is a geometric mean between 4 and 9? So you're going to say 4 is to, I don't know, x as x is to 9. And again, this is coming from your right triangle. Okay, right there, right here, and you've got this triangle here, similar to this right side here, that triangle here, similar to the big triangle. Okay, so what you're looking at here is this is 4, this is x, and this is 9. So you're saying 4 is to x as x is to 9. Cross multiplying this, okay, if you cross multiply this, let me see if I can move that down. There we go. Cross multiplying, I'm going to get x squared is equal to 36. And again, we just talked about this on the previous slide. To get x, to solve for x, we're going to square root both sides. And in doing that, I get x equals, technically, if I was in Algebra 2, I would say plus or minus 6. But again, if you think of x, this is x right here. This is my height. -6 is not going to be one of my solutions, okay? So that's going to be gone. You can only have a positive value. So my answer would be x equals 6. So a couple of these problems here just asked, find the geometric mean. So between 3 and 9. So if you, and then there's three questions here. If I were you, I would stop the video and then I would work these 3 problems out and then start the video again. So assuming that you did that, to find the 3 geometric mean, or to find the geometric mean between 3 and 9, you would say 3 is to x as x is to 9. You would cross multiply and you are going to get x squared is equal to 3 times 9, which is 27. And to solve this, I'm going to square root both sides, and I'm going to get x is equal to the square root of 9 times 3. Keep in mind, this is actually equal to the square root of 9 times the square root of 3. Well, what's the square root of 9? Square root of 9 is 3. So my answer is 3 root 3, and that's going to equal to x. Okay. To find the geometric mean between these two numbers right here, okay, I'm going to go 5a cubed b c squared is to x as x is to 4a b c. And I'm going to try to drop this down just a little bit so I have a little bit more room. Okay, so for this problem, we're going to cross multiply. I'm going to go x times x, so I have x squared is equal to this times this. So we're going to go 4abc times 5a cubed b c squared. Now, keep in mind a couple of things, and depending on how you learned square roots, etc., when you were in Algebra 1. And I'm going to simplify this before I finish solving this, but the rule is when you're just multiplying, okay, before even we square root. So let me even erase the square root here. Let me see if I can get rid of that. There we go. Before we even get rid of the square root, a way to simplify, let's say the right side, okay, is to remember multiply, numbers get multiplied with numbers. So 5 times 4, that's going to be 20. Now, a times a cubed, there's a rule for that. Remember, it's keep the base. If the variables are the same, you keep the base and add the exponents. Okay, so you're going to say this is 20, a to the 3 plus, there's a 1 here, even though you don't see that, but that's 3 plus 1, which is 4. And then you have b1 here, so that's going to be b squared. And then lastly, you have c to the 1, and then c squared, so that's going to be c to the 2 plus 1, which is 3 power. So what you have, okay, when you simplify this, okay, and let me erase these two for right now, is x squared equals this. Now, keep in mind, this right here, oops, try to get these all over here, bring that down here. There we go. Okay, so we have that equals x squared. So when I square root this and I square root this, okay, you're square rooting this whole thing. Remember what a root is. The square root, a variable, the square root, or x, the square root of x is, let's say, x to the 1/2 power. So you're actually taking a 1/2 power. So what if I had x squared here? And then I had the square root of x squared. Well, that's going to be x squared to the 1/2 power. 2's cancel. I have x by itself, right? So really, what if I had x to the 4th power, okay? That would actually be x to the 4th to the 1/2 power. So that's going to be 2. So what you're doing is, when you're taking a square root, is you're cutting your power in half. And if it's an even power, that makes it super easy, because what that does is you're just cutting your power in half. Okay, so what you're doing here is the square root of x squared is just x. The square root of 20, we can do that on the side. That's the square root of 4 times the square root of 5. The square root of 4 is 2, so that's 2 root 5, right? So we can take out a 2. We still have a root 5 in the middle. So far we have a 2, and then we still have the root. For a to the 4th power, remember, a to the 4th power, the square root of a to the 4th is just a squared. It's a 1/2 power. It's a to the 4th to the 1/2 power. 2's cancel. So this is now I have, if a to the 4th, I have an a squared out. Okay, that's gone. Half of b squared, half of that, that's gone. Now this one's a little bit tricky, because depending on how you learned this, a lot of teachers taught you that this is actually c times c times c. And I know your teachers may have said, well, you have 2 of something, 1 comes out. You can do it that way, but just keep in mind, this is actually c to the 3rd power. And if you have c to the 3rd power, and you remember it's a 1/2 power, it's a square root, that's c to the 1.5. So that means like 1 value is coming in, and I still have a 1/2 power inside, which is a root. Okay, so root 20, remember, I still got the 5 under here. The a came out. the B came out when I cut that in half, and I still have one C left. So my final answer for this problem right here is 2a squared b c times the square root of 5c. And lastly, we want to do the geometric mean between 64 and 49. So you're going to go 64 to the x is to x as x is to 49. We're going to cross multiply. X squared equals 49 times 64. And again, you're welcome to multiply that out, but it's not necessary, because when you take the square root of these values, you're going to get the same thing as saying x equals the square root of 49 times the square root of 64. And the square root of 49 is 7. And so you have 7 times 8. So x is equal to 56. And that's my value. Okay. So where does the geometric mean come from? So if the altitude drawn to the hypotenuse of a right triangle, if it is, then the two triangles formed are similar to the original triangle, and they're also similar to each other. Meaning what you do is, I don't know if you can see this. I think this is green here. You have a smaller leg here. This small leg is similar to this small leg on this triangle. So you have a triangle that looks like this. Okay. Then you have this triangle here, which your smaller leg here and long. Okay, that's this one here. Okay, I didn't do a very good job with that. And then you have, okay, and then so that's this one. There's this one here. Okay, so these are these two. But what you're looking at is this smaller side here, and you're looking at this smaller side here, which is similar. Like those are the same leg. Okay, and then what you also have is your hypotenuse, right? There's that hypotenuse, and then here's your other hypotenuse here. Not to forget the big triangle, okay, that has the hypotenuse right here. And then again, you have your short leg right here, which goes to this leg here and this leg here, or that's your hypotenuse, sorry, your hypotenuse. And then you've got your short leg here, short leg here, short leg here, short leg here. And then you've got your longer leg. So there's your longer leg. So then you've got your longer leg here, and you've got your longer leg here. So these are lots of proportions, so I'm going to show you how to break those up. But what's going to happen is mostly, I like this formula. Not everybody uses it, but it's one way to remember the proportions. And it's any one of these small or large triangles. It's the hypotenuse to leg as hypotenuse is to leg. So it could be the smaller hypotenuse to the smaller leg as the larger hypotenuse to the larger leg. Okay, so just remember that these go with each other. So if you go small hypotenuse, small leg, large hypotenuse, large leg. Okay, so think about it like this, that if I was looking at this left triangle right here, okay, and I was comparing this left triangle right here to the large triangle, okay, if I was doing that, I would go the hypotenuse. So I would do hypotenuse is to small leg as hypotenuse is to small leg. And so try to imagine that with the picture on top of it. So let's do that. Okay, let me see if I can do it with this. Hypotenuse is to small leg as hypotenuse, okay, is to small leg. So you have to try to see that with the triangles separated. Maybe if that helps, I don't know. Everybody's different in learning these. So let me show you what this does. So for this one, if we did small leg, you're looking at AD is to CD as CD is to this value right here, and that value right here is going to be BD. BD or DB, either one, okay? For this one, you would say AD, so here's AD, so AD is to AC. So what did they just do? They did leg is to hypotenuse. So they did leg is to hypotenuse as, so now I have to do leg again. So this is my smaller leg, right? Leg is to hypotenuse. So AC is to the whole hypotenuse, which is AB. And then lastly, you have BD. Where is that? BD. So here's BD. So that's a leg is to my hypotenuse, which is BC. All right. Leg as to hypotenuse as BC, which is that is a leg in my big triangle as to my hypotenuse, and that's going to be AB. So a couple ways to remember this is the short side is to the long, and the short side is to the long. And again, this one's left to right. So that's, you could do that. This one is the small leg to the hypotenuse, as small leg is to the hypotenuse. Large leg is to the hypotenuse, as the large leg is to the hypotenuse. So again, the way you say them, that's up to you. This is right here. You have CD. Is the geometric mean of AD and BD. And then you have blank is the geometric mean. So this is AC is the geometric mean of, this is going to be AD and AB. And then blank is, so this is going to be BC is the geometric mean of BD and AB. Okay. So let me move this up so you can see that. Okay, so those are all the different ways that you can actually write the different proportions. I do want to just remind you that you can always fall back on hypotenuse to leg as hypotenuse to leg. But keep in mind that if you're using small, right, and this could be the larger one. Okay, so just keep in mind, if you do smallest to small, largest to large, you can also go smallest, large. It's up to you how you do that, because ratios can be done so many different ways. So let's practice, okay? This is in your homework packet. These are just some practice problems. This is number 7. So let's put the values in. So I would recommend that you use a pencil, because if you use a pencil, then you can erase on here every time you do this, and you have, 4 problems. So HG is 6, so there's 6, and EH is 24. Your job is to find FH. So this one is a regular mean. We have base is to height as height is to base. So that's really just saying 6 is to X as X is to 24. Cross multiply, you have X squared equals 6 times 24. And I'm going to square root both sides, okay? So I have X equals, now for this problem right here, you have 6 times 24. Let's rewrite this, and that's 6 times 24, which is 6 times 4. So what we have here is root 6 times root 6 is 6. Root's 36, which is 6. So that's 6 times, and the square root of 4 is 2. So 6 times 2, which is 12. So this value is 12. You also could have multiplied these out. You could have also multiplied these out, and in multiplying these out, you would have gotten, let's see here, X is equal to the square root of 144, and then of course that's 12. Okay, so the next one, we're going to erase this because we're now on to problem number 8. And so problem number 8 says FH is 16. You've got HG, which is 8, and EH is unknown. So again, this is base is to height as height is to base. So you're going 8 is to 16 as 16 is to X. I'm going to cross multiply. I get 8X equals 16 times 16. I'm going to divide by 8 on both sides, and I'm going to get X is equal to, let's see here. I know that 8 divides into 16 twice, and I've got 2 times 16, which is 32. So my solution is 32. Okay. The next problem, I'm going to erase it again to get to the next one. It says EG is 27. So EG, so the whole length down here is 27. HG, that's this length here, is 3. Your job is to find FG. So your job is to find this value right here. So unknown. So cool. Let's do that. What that is it looks like I have a hypotenuse. See my hypotenuse to my big triangle. That's the hypotenuse to the big triangle. So you're going to go hypotenuse leg. So I'm going to go 27 is to my small leg on my large triangle. Okay. As now I'm going to go hypotenuse on my little tiny small triangle right here. What's the hypotenuse? Well, the hypotenuse is X. So as X is to the little leg 3. So we're going to cross multiply. We get x squared equals 27 times 3. X squared equals 81. I'm going to square root both sides. So I get x is equal to 9. And then the last one, this one's a little bit small. I'm going to actually try to make that a little bit larger for you. Sorry about that. So you can see those. This one says if EH, oh, I need to erase this real quick. Start over. That's why you use pencil, so you can do that. So the next one says if EH is 16 and EF, where's EF, is 24, find HG. So that's this value here. So what you're going to do here is, there's a couple things you can do. We haven't technically done Pythagorean theorem, but we will be doing that today. Just so you know, you could do a squared plus b squared equals c squared, get this value here, and then go base is to height as height is to base. One option. Second option is I'm going to go hypotenuse leg again. So I've got my hypotenuse right here. So this hypotenuse is x plus 16 is to my leg, which is 24. Do you see that? So hypotenuse is to leg. Okay, this is a right angle. Okay, so hypotenuse is to leg, and I'm talking about the large triangle right now. Hypotenuse is to leg as, now I'm going to talk about just the small triangle. So as hypotenuse is to leg. So as 24 is to 16. Okay, so with this one, it's, it does involve a little bit of math, and maybe you need your calculator. So 16 times the quantity x plus 16 is equal to 24 times 24. And what you can do to make your numbers a little bit smaller is if you don't have a calculator, on both sides, I can divide by 16, meaning I'm going to cancel this divided by this, and that's going to make 1. And 16, I'm going to split 16 up and divide that, make that into 4 times 4. Because in doing that, I'm going to go 4 divides into 24 6 times. And then this 4, and this goes once, divides into this 24 6 times. And so now I actually don't need a calculator. I've got x plus 16 on the left is equal to 6 times 6, which is 36. I'm going to subtract 16 from both sides, and I get x is equal to 20. Okay, so there's my answer. So this is just another geometric mean. We've done a couple of these now. So there's t. So that's the geometric mean between S and R. U is the geometric mean. So that's either a leg or a hypotenuse. So these ones right here, so take a moment, stop the video, try to fill these in, what these values are. U is between R and K, X is between, there's your answers are right here. S and R, you've got U is between R and K, you've got V, this is V, is between X and K. So you just, what you've got is, just, there's no value there. So what you've got is this is a leg. So you've got this leg is a hypotenuse. So that V goes with this K here. Also with this U. So I believe this should be U and K. Let me fix that. Okay. So now what you've got is we're starting with the Pythagorean theorem. And so a lot of people, most of you have seen this before, or you've heard of this. Pythagorean theorem, meaning a squared plus b squared is equal to c squared. And there's some really cool proofs that all have to do with area. Like if you were to make a square of this, right, c times c, and then you made a square over here, and then you were to make a square over here, basically the areas of a squared and b squared equal the sum of the areas of a squared and b squared add up to be the sum of c squared. So there's some really cool online proofs, and I know you did a lot of this in Algebra 1 last year, but for geometry, we're just reviewing this in that the leg, so this is considered a leg, right? And so most people start using a squared and b squared, and then they get confused when people use different letters. So you got to be careful about that. This is a squared plus b squared, meaning a leg squared plus a leg squared equals the hypotenuse squared. That's what that's saying. Okay. What is this? This right here is what this is just another right triangle. Instead of using the variables a squared plus b squared equals c squared, that you can rewrite that as x squared plus y squared, because that's a leg here. That's a leg here. X squared plus y squared is equal to z squared. Okay, so a couple of things. Sometimes they don't give you z, and then you would use this formula. But let's say you were trying to find x, and x was my unknown. You're trying to find that. Well, you could use x squared is equal to z squared minus y squared. Or if you were trying to find y, you could say y squared is equal to z squared minus x squared. So don't get too familiar in thinking that every single time z is the unknown, because it's not, okay? You're going to be working to try to find different sides. We have something called Pythagorean triplets. And what these are, the triplets, are basically there's three numbers that basically work all the time with a right triangle. So if I had a right triangle, okay, and I knew that one of my sides was 3, you know the hypotenuse is always going to be the largest side. There's 3, and then you have 4, and then here's 5. 5 is going to be my hypotenuse. If I wanted to prove that, I'd go 3 squared plus 4 squared. Does that equal 5 squared? So we have 9 plus 16. Does that equal 25? And 25 is equal to 25. So what these are triplets. Triplets are basically a set of 4. This is 4, okay? And they're numbers that you see really frequently when you're solving right triangles. And basically what's going to happen is you'll see a right triangle, and most of the time you'll say, okay, here's 5, here's 13, what's this side? Well, most people will go, okay, 5 squared plus x squared is equal to 13 squared. And they'll work through this whole thing and then not realizing that it's a triplet, meaning my missing side is 12. Now, they could figure it out, of course, going x squared is equal to 169 minus 25. So x squared is equal to 144, square root both sides, x equals 12. Check, got it. But these are a set of numbers that actually work very frequently. And so you're going to see these a lot. So if I were you, I would memorize these because, like I said, you're going to see these a lot. Now, I don't know, there's some cool patterns that deal with this, but they don't work for all the numbers. So let me show you what I'm saying. 4 plus 5 is 9. Square root of 9 is 3. Boom. 12 plus 13 is 25. Square root of 25 is 5. Let's try this one. 24 plus 25 is 49. Square root of 49 is 7. But this one doesn't work. So yeah, they don't work all the time. So it's not a thing. It's just a thing sometimes because it only works sometimes. So anyway, I think that's kind of neat. So again, these are just Pythagorean triplets, and basically you're going to see these a lot. So again, I think I told you maybe 4 times, memorize these numbers. Okay, you've got 3, 4, 5, 5, 12, 13, 8, 15, 17, 7, 24, 25. So try to just remember what those numbers are. A lot of people think of this one, like this one's very popular, 6, 8, 10. People look at that and they go, oh, that's a triplet. But that's not a triplet because it's a multiple of a triplet. Like if I were to divide each one of these by 2, right? Divide by 2, divide by 2, divide by 2, I'd have 3, 4, 5. Oh, that's a triplet. So you're going to see a lot of triplets. Like what if I multiplied each one of these by, or 3, 4, 5 by 3, right? I'd have a triangle and it would be what? 9, 12, and 15. Well, a lot of people see that triplet, those trio of numbers. It doesn't mean that those are triplets. Those are multiples of triplets. These are the only triplets that you're going to see. All right. So what we have here is using the Pythagorean theorem. I want you to use the Pythagorean theorem. So you would go x squared plus 4 squared is equal side squared plus side squared equals hypotenuse squared. So x squared plus 4 squared is equal to 12 squared. So you'd go x squared plus 16 is equal to 144. You're going to subtract 16. So if I subtract 16 from both sides, let me erase this part right here. If I subtract 16 from both sides, I get x squared is equal to borrow. That's 8, borrow 3, 2, 128. So you're going to want to reduce that. So you're going to get the square root of both sides, right? So you have x equals the square root of 128. Now, I'm guessing that 4 at least will go into that, possibly another number, but let's look. So x is equal to the square root of, 4 divides into that how many times? We're going to say 4 times 32. Okay, well, the square root of 4 is 2. So now I have 2 root 32. But that also could be reduced, right? 32 is actually, we're going to rewrite that as 2 times root 16 times root 2. Because remember, root 32 can be broken down. So now we have x equals 2 times 4 times root 2. So x is equal to 8 root 2. So what does that tell us? Okay, what that tells me is right here. I could have thought of a bigger number, like square root of 64. Isn't that square root of 64 times the square root of 2? Well, the square root of 64 is 8. I could have done this right here and said, oh, there we go. We have 8 root 2. I could have missed all of this stuff down here and done that if I had thought of a bigger number. So always try to think of the biggest numbers that you can, the biggest perfect squares that you can to go into one of these roots right here. But if not, keep in mind that you can kind of fiddle down to the bottom and get to where you got to go anyways. Now this one, again, this is a triplet, 6, 8. Well, not a triplet, it's a multiple of a triplet. So we know that z is equal to 10. But just for fun, let's go 6 squared plus side squared plus side squared. So again, notice that for this problem, my x was one of my legs, okay? And for this problem, my unknown is my hypotenuse. So it's not going to be that every time, right? So 6 squared plus 8 squared is equal to z squared. So 36 plus 64, which is 100, is equal to z squared. And if I square root both sides, you're going to get z is equal to 10. So just keep in mind that if you recognize that this is a triplet, 6, 8, 10, or a multiple of a triplet, you don't have to do all this work. Whereas, sometimes you have to do that work because you have to work it out. But if you recognize something as a multiple of a triplet or a triplet, then you can alleviate some of that work for yourself. Okay, so what these two problems have in common is that there's a lot of errors. These are just wrong, okay? They're wrong because if you look at this, see how it goes x squared equals? Again, a lot of people look at this and they go, because there's an x here, right? They think that you have to set your problem equal to x. So don't get in that habit. Try to get in the habit of going leg squared plus leg squared is equal to the hypotenuse squared. So you have 5 squared plus side squared is equal to 12 squared. So, right, that would be 25 plus x squared is equal to 144. Subtract 25, I get x squared equals 144 minus 25. I'm going to have to borrow again. So 9, that's 3. 3 minus 2 is 1, and then 1. So 119. So I've got x is equal to the square root of 119. Okay. And because you don't have a calculator right now, you can approximate that because that's in between. The square root of 100, that's 10. And that the square root of 121, which is, see the 119, you see that, right? That 119 is in between that, and that's 11. So this is super close to 11. So I might even say that this is like 10.8 or even 10.9. So if I wanted to approximate like what the answer is, it didn't ask me to do that. It just said find the correct solution, which we did. Check. Okay, we're done. For this problem on the right, I love this problem because not because everybody makes mistakes with this, but they actually do. See this squared here? I know this is like super small here, but that says 2 root 5 squared. Okay, so that's wrong. When you go 4 squared, leg squared plus leg squared equals hypotenuse squared, you actually have to square the entire value, okay? So not only is that a problem, but what's a problem is like actually squaring that because so many people mess up with that. So what it is it's 4 squared plus x squared is equal to 2 root 5, okay? Quantity squared. The whole quantity is squared. So that's 16, that's x squared, but this is the part where people mess up. 2 root 5. How do you do that? Okay, so let me show you how to do that. Let me erase this so it gets out of my way. Okay, hold on. Let's move this. All right, so what you're looking at is 2 root 5. That's going to be the whole quantity, 2 root 5, as a quantity times itself, 2 root 5. So what you have is numbers get multiplied by numbers. So what I should multiply is 2 gets multiplied by 2, so that's 4, okay? And then you have root 5 times root 5, because numbers get multiplied with numbers, roots get multiplied with roots. And root 5 times root 5 is root 25, and root 25 is 5. So this little part here is actually 4 times 5, which is 20. So you have 16 plus x squared is equal to 20. Subtract 16. I get x squared equals 16. No, that's not right. I get x squared is equal to 4. Okay, I'm going to square root both sides, and then I get x is equal to 2. All right, and that's a solution. Okay, cool. This is a homework problem. The length of one side of a square is 6 inches. What is the length of the diagonal? So the diagonal is this length here. Okay, that's one diagonal. Remember, it's a square. So both diagonals are going to be equal. So just pick one to draw. Also, on a square, all sides are the same. So you can go 6 squared plus 6 squared is equal to my diagonal. I don't know what that is, squared. So there's my unknown. Leg squared plus leg squared. So we're going to go 36 plus 36 is equal to x squared. What does that make? 72 is equal to x squared. And then we're going to square root both sides. Now, a couple of ways I can do this, right? Let me show you a couple of ways to do this. So we already know that this is x equals, because the square, remember, the square root of x squared, so x squared to the 1/2 power, 2's cancel, I just get x. So this value here is just x. Check. Now, root 72 can be done. Let me show you 2 ways to do this. So here we go, root 72, and we're going to do it again, x equals root 72. So let's say you're thinking big numbers like 36. So I can say that this is x is equal to the square root of 36 times the square root of 2. The square root of 36 is 6, so we have 6 root 2. So that's my answer for this solution, meaning my diagonal is value, its length is 6 root 2. But let's say I wasn't thinking such a large number. I was thinking, oh, I know that that's 9 times 8. So it's root 9 times root 8. So, well, the square root of 9 is 3, right? So that's done. But now I have 3 root 8. But that's not even reduced, because root 8 can be reduced again. That can be root 4 times root 2. So now what I have is 3 times root 4 times root 2. These are all multiplied, right? So x is going to equal, this value here is 2. So I've got 3 times 2, which is 6, root 2. And so that's my answer again. So you have choices. There's so many ways you could have done, broken down root 72, but those are just 2 ways. So this is super important. This is a good SAT question, just FYI. So this is the converse of the Pythagorean theorem, all right? So the converse of the Pythagorean theorem is basically saying, if it's not a right triangle, then it's either obtuse or acute, or neither, okay? All right, so let's think about this. If c squared is equal to a squared plus b squared, okay, that's your Pythagorean theorem, right? If c squared equals a squared plus b squared, then it's a right triangle. All right, check. We know that. We just spent 5 minutes doing that. But if c squared, see this greater than? That's a greater than. If c squared is greater, what does greater mean? Greater means obtuse. So if c squared is greater than a squared plus b squared, then it's an obtuse triangle. And if c squared is less than means acute. So if c squared is less than a squared, the sum of the 2 legs, okay, or the other sides, the smallest, this c is going to be my biggest side, okay? It's always going to be my biggest side. Then it's going to be an acute triangle. Now, I want you to see what I wrote is or neither. Neither, because remember 3 sides of a triangle? do you remember the formula that basically says that two sides have to be greater than the third side? Okay, that's the thing here. So you need to remember that. So if you have 2 and you have 3 here, 2 plus 3 is 5. You can't have this be 5 because the sum of the sum of two lengths has to be greater than the third side. And if it's not, this triangle doesn't exist. It actually looks probably something like this, where it's just like this. It doesn't exist, okay? So again, you could have had 2 plus 3 has greater than the third side. If you said 4, okay, that works because 5 is greater than 4. 2 plus 4 is 6. 6 is greater than 3. And then 3 plus 4 is 7. 7 is greater than 2. So that would be okay. But watch out for tricky triangles, okay? So these triangles right here, to see if they are right, obtuse, or acute. So this would be a good time for you to pause the video and to try these 3 problems on your own, and then we'll see how you do. So assuming you did that, you stop the video. Let's see. We're going to remember, always take the bigger side first. So biggest side, biggest side, biggest side. So c squared, that's my c. Okay, that's my c. So c squared. So we're going to go 10 squared is what? Not sure. To 7 squared plus 8 squared. So this is 100, and this is going to be 49, and what is that? 64. Well, see, that's 100 is less than 49 plus 64, so that would make this acute if it's less than, okay? How many of you recognize this as being a Pythagorean triplet? Okay, I'm not sure if you did or not, but what we do, again, we take the biggest number. 17 squared is what? To 8 squared plus 15 squared. So 8 squared is 64 plus 225. And so what is that? 64 plus 64 plus 225. What's that? 289 is what? Oh, 17 squared is also 289. So these are equal. So if these are equal, then it's a right triangle. And lastly, we'll take the biggest side. Don't forget, 3, 7, 9. 3 plus 7 is 10. 10 is greater than 9. Check. If this had been 3, 7, 10, then this triangle didn't exist, right? Because two sides, the sum of two legs, has to be greater than the third leg, but not the same value, okay? So that would have been a non-existent triangle. Again, so we go 9 squared. So 9 squared is what? To 3 squared plus 7 squared. So we have 81. 81. Okay, do this again. 81 is what? To 9 plus 49. So 81 is greater than, okay, so if it's greater than, it's obtuse. Okay, so we have, if it's less than, it's acute, two sides, right? Okay, then you have equal, and then you have obtuse. So you always put the C first, because that helps you to remember that the other two sides are greater than or less than. So anyway, that concludes the introduction to right triangles, and I hope that helps. All right, see you next time.